In section 6.1, we are talking about inequalities, and we're going to solve with addition and subtraction. So to begin, we're going to write out how you would verbally say each of the symbols. The first one is just an equal sign, so you would say equal. The second one is going to be less than or equal to. Now, how do you know that? Because the less than, or the smaller end of the mouth, comes first. The line under there also means the equal to. So if this one's less than or equal to, if we flip that so that the big end comes first, the big part of the mouth, this is going to be greater than or equal to. And then the other two symbols do not have the line for the equals part, so this is just going to be less than, and this one's just going to be greater than. So if we look at what numbers would make some of these inequalities a true statement, we want to find numbers that if we plug it in, it's true. So what numbers could we plug in for x so that x equals 5? For this one, only 5. If you plug in anything else, it would make a false statement, because 3 doesn't equal 5, -6 doesn't equal 5, 0 doesn't equal 5, so on and so forth. For the next one, x is less than or equal to 5. We could plug in 5 because that's equal to. We could also plug in 4 because that's less than. We could plug in -17, anything that is 5 or smaller. The next one, x is greater than or equal to 5. So again, because it has the equal to part, we could put the 5 in there, but we could also put anything bigger. So we could do something like 6.5, 100, anything bigger than 5. The next one, x is less than 5. This one we cannot use 5 because it doesn't say equal to. We can say 5.5, however. I'm sorry, nope, this is less than. We can say 4.5 because that is less than 5. We could say 0. We could say -1. Anything that is smaller than 5 and does not include 5. Now the last one is where x is greater than 5. So again, it does not have the equal to part, so we may not use 5, but we could use 5.5. We could use 5.01. We could use 100. Anything that is greater than 5. Now finally, let's take a look at what it would look like if we graphed each of these things on a number line. The first one, x equals 5. There's only one answer to this. So if we put 5 on the number line, we would just have one dot at 5. And to show some direction, you could put 0 on here somewhere also. X is less than or equal to 5. Again, if we have 0 and we have 5, we know that 5 is going to be part of our answer, but we also have everything that's less than that, so we would shade to the left-hand side where all of the lower numbers are. We want to shade where all of these possibilities lie. So all of these would be in the shaded region. So for the next one, x is greater than or equal to 5 if we have 0 and we have 5. Again, 5 is going to be included. But this time, all of these numbers, in order to be in the shaded region, would be to the right. That's the direction where the larger numbers are. The last two do not say equal to. So 5 is not going to be included. So if we put 0 and we put 5 on our number line, again, just to show some direction, we are actually going to put an open circle on 5. That means that everything up to 5 but not including 5 will work in this inequality. But all of the numbers in the shaded region to the left, or the lower numbers, or the numbers that are less than 5, will still work. So for the last one, 0 and 5, we want the numbers that are greater than 5. Again, 5 does not work, so we will put an open circle there as opposed to the closed circle, and we will shade to the right. So as a rule of thumb, if there is an equal sign, a less than or equal to, or a greater than or equal to, this is going to be a closed circle. If it is just greater than, or if it is just less than, this is an open circle.